and the word domain. So first of all, a function is an equation where the x value has one and only one y value. A function is an equation where the x value has one and only one y value. Don't worry, I'll explain that to you. Go for it, man. An equation where the x value has one and only one y value. So let me give you an example of this. I'm going to draw a table real quick. And I'm just making this table up, okay? So just bear with me. Like if my numbers are kind of goofy, just understand I'm literally making it up. For x, if I tell you that x is equal to 0 and y is equal to 2. If I tell you that x is equal to 3 and y is equal to 9. If I tell you that x is equal to 10 and y is equal to 12. Notice that my x value is never ever repeating. Do you understand that? An example of a non-function would be this. 0, 2, 0, 3, 5, and 1. Can anybody tell me why that would not be a function? And it's not a hard question, it's just why is it not, Colin?
Because the 0 repeats.
Because the 0 repeats. Okay? So we're all on board with kind of how that sounds so far. I'm not done explaining it, I just want to make sure you guys see the table reference. All week, this entire unit is about functions. So if you can understand this general idea, then the rest of it comes back a little bit smoother. Okay, we're good there? Daniel, did that help at all?
Yes.
Okay, perfect. All right. So now, what I'm going to do is I'm going to draw a graph, and I want to describe you a function that way. Do we agree this is my x-axis?
Yes.
Do we agree this is my y-axis?
Yeah.
Is this a function?
No.
Why?
Because it's a circle, and circle means the x value will repeat.
Ah, very good. I was really glad that he said it's a circle and then continue, because if Hayden had just said it's a circle, it wouldn't have really answered my question. Let me prove that to you. Do we agree that this is the origin? And Zoe, what is the point of the origin? Like, what is the actual ordered pair? 0, 0. Yeah, great. And what number comes first in your ordered pair, the x or the y value? X. Always x. When you say the alphabet, how does it go? Do you go y, x, z? No, you say x, y, z. Therefore, x always comes first. So is it safe to say that this point could be 0, 5? And is it safe to say that this point could be 0, negative 7? I mean, I'm just estimating, right? But can we all agree with that? And do we agree that 0 is being used on both of those? So therefore, it's not a function. Are we good there?
Yeah.
Okay, I'm going to draw on this same graph just for simplicity purposes. What if I draw this type of line right here? Do you think that's a function? Erase the circle, clear it out of your mind. But if I just draw that straight line,
Yes. Yes.
it's a function, right? Because notice, my x values were at negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We're all good with that? Okay, that's the basic all you need to know for a function today. Thursday, we'll go a lot more in depth with this, but today that's where I need you to be. Good? All right, cool. Function notation. Okay, let's think back to yesterday's warm-up. Yesterday's warm-up, I gave you that really weird problem. You thought I'd lost my mind because I had a whole bunch of random variables. This is what we call function notation. The reason we call this function notation is because this F right here doesn't stand for fire truck as much as you would like to think it does. It stands for function. So what this is saying is the function of x is equal to 3x plus 5. So here's what I want you to add to your notes. F of x equals I'm sorry, not, it equals the function of x. F of x means the function of x. I'll let you write that down real quick and then I'll explain to you what I mean by that. Can you guys all see that okay, or is it too dark? Is it okay? My glasses keep fogging up so I can't really tell, so I'm just checking on y'all. Okay. The function of x, or f of x, in a simplified version, function of x. So let me explain to you what that means. When you see this f right here, that means that this next side over here is a function, meaning that there's only one value for x for every one value of y. Okay? F of x also means, you might remember from yesterday what I told you it meant? Anybody? Anybody? Steven?
Y.
Yeah, very good. F of x also means y. Now, more times than not, you're going to consider f of x to just be y. 90% of the time, that's how you're going to think about it. But I want you to know the true meaning of it. I don't want to just give you the easy way out on these things. At some point we can, but as of right now, it's not where we're at. So, f of x, or y, or the function of x. Now let me put this into practical terms for you. For this particular problem, can I erase these two? Are we okay with that? Yeah, perfect. In all actuality, what this is really wanting you to do is it's going to give you a problem that looks like this. Let's think about what this is saying now. This f stands for what? Function. So the function of x, do we agree that this is letter x?
Yes.
And what if I replace letter x with?
3.
So what do you think I'm going to replace the letter x with in this problem?
3.
Very good. So here's how this problem would now be written. The function of x, when x is 3, is equal to 3x plus 5. I'm sorry, let me, my bad. My D.
What?
Again, the function of x, I replaced x with the number 3, so then therefore I substituted in the number 3 for x in the problem. And so what this is really saying is when the function of x is 3, it's going to produce an answer over here. Now, did you guys solve this?
Yes.
It's just like our warm-up, right? What is 3 times 3?
9.
Plus 5. So what this means now is that when x is 3, y is 14. And what can we do when we have an x and a y value? You can graph it. You've made an ordered pair. And so therefore, we can now take that point and put it on a line. And if I change my value of x, if I change the function of x, it would then produce a different y because for every one x value, there has to be one and only one y value. Does that kind of make sense? Again, this is day 1. I know I'm going on. Go for it. You're good. I appreciate being respectful. You want another one?
Bennett.
Do you want a superior pencil? I can give you 2 to choose from. All right, cool. Thank you. All right, are we good there? Are you following me so far? I'm going to move past this. We'll come back to it. This is our whole focus today. If you can comprehend what I've done on this screen right here, you're doing good. We're going to practice these today. We're going to practice these tomorrow because ironically, this is one of the most missed teaks that I teach in my class. And here's why. Oftentimes, when you're given this problem, it won't plug into 3 for you. It'll give you an example of it, and you'll have to know where to plug it in. So you would have to plug it in over here. Okay, I'll get to that later. I'm jumping ahead. All right, and finally, the last vocabulary word I want to talk about today is the word domain. Domain. D-O-M-A-I-N. It sounds like some super nerdy Dungeons and Dragons video game, right? Board game. I like board games. No hate. Domain. Domain are all of the x values in a set. All of the x values in a set. Katie, how am I on time?
9:59.
Perfect. So all of the x values in a set, let's just create a table real quick. 2, 3, 4, and 5. This is my x. So the domain of this problem would be 2, 3, 4, and 5. My y values don't matter. That's a totally different word. We'll talk about what y's are, and just in case you're curious, it's the range, but I'm going to talk about that one tomorrow. Okay? So your domain would be 2, 3, 4, and 5. Okay? Just for funsies here, can anybody tell me what the domain of this line would be? Katie?
2, 3, 4.
2. No, good guess. Good guess. Steven?
Around -2.
Around -2, is that what you're saying?
Yeah.
More than that. There's more than that. What does domain mean?
All of the x values.
All the x values in a set. All of the x values. Carter, what do you think?
-2, -1, 0, 1, 2, 3.
What if I add these to it? Does that help a little bit? So that does mean it goes on forever. So you might want to take an educated guess on what it would mean for my domain.
The domain
Close.
never ends.
All real numbers. All real numbers. Let's think about it. If this line goes on forever and ever and ever, does it ever stop? So can I just say 2 billion? No, because 2 billion, although it's a very large number to us, is a relatively small number in the grand scheme of mathematics. Agree? So it would be all real numbers. Let me throw another trick one here. Again, I'm just throwing these out here just for fun. What about the domain of this line?
There it is.
It will be just one number, like x.
I agree, it will be one number. Can somebody just give me an estimate of what that number could be?
3.
7, sure. 3, 7. But do we agree that right here this would be, excuse me. This paper. Hey, what's up, man? You're good. I do, but it's all good. So we don't have an official like lead time to this for our PLC speed. So that would be from 3:18 to 4. Let's do today. And basically what I'll do is just I'm gonna leave it open for people. There were just some questions yesterday in our struggle that I think would just be helpful to hear some solutions to. So if you don't mind, that'd be awesome. Awesome, thanks, man. All right, y'all. Sorry about that. Might be. So yeah, so this would be 0, 3, and then we agree this is like,
Mr. Kramer,
yeah,
13.
oh, perfect. I'm sorry, this is not 0, 3. This would be like 3, 0. This would be like 3, 1, 3, 2. Does everybody see why I'm able to say it's only 3? Because the x is constant. So let me ask you this, just to tie this in before I end this video. Is this a function?
No.
Why? Because the x is repeating over and over and over. All right, last one. Again, we're going to talk about this more. I'm just introducing it because you guys are answering the questions well. What about if I give you this line? First of all, what do you think my domain is? What do you think my domain is?
-5, -4, -3.
You're on the right track. What do you think? All real numbers, right? Because it's not ending. Whether I put the arrows there or not, we're going to assume it's always going on. Okay? Is this a function? Whoa, we got a split answer.
Yeah.
Ready to think it's yes. Ready to think it's no. JT, why do you think it's no?
Because it will always be the negative or the positive number because it's always going to cross.
Give me an estimate of what this point is right here.
Like 6.
-6, 3. How's that?
Yeah.
What about this point right here?
Maybe like -6.
Ooh, negative. Where do you get negative from? How about 2, 3? So what's repeating, my x or my y?
Y.
I didn't say anything about y couldn't repeat. I just said x couldn't repeat, right?